So in this video, we're going to look at parametric differentiation. I'm going to pick up an example question here. The question says, if x is equal to 2 cos theta minus cos 2 theta and y is equal to 2 sin theta minus sin 2 theta. So you can see that x is written in terms of theta and y is also written in terms of theta. So theta is the parameter here. So both x and y are written in terms of theta, are written as functions of theta. And your question is to find out dy by dx. And the question is actually asking you to prove that dy by dx is equal to tan 3 theta by 2. And then I'm also going to discuss the second derivative. Also find the second derivative, d square y by dx square. So you differentiate your dy by dx one more time to get d square y by dx square. So let's look at this. I have got x given to me. So I copy that. X is 2 cos theta minus cos 2 theta. Since x is a function of theta, I can differentiate x with respect to theta, that is dx by d theta. So I'm going to find the derivative of x with respect to theta. 2 cos theta, derivative of cos theta is minus sin theta. So 2 cos theta is minus 2 sin theta minus cos 2 theta derivative is minus sin 2 theta into 2, the inner derivative. So here double minus will become plus, and then there is a 2 common factor. So I'm going to take 2 common out, and so this positive term minus minus is plus sin 2 theta. So I write that first, the positive term is placed first, and then minus sin theta because I took 2 common out. So that's what I have there, and then that looks like sin A minus sin B, and sin A minus sin B has a product formula. Sin A minus sin B is 2, of course this 2 outside the bracket I already copied, and then sin A minus sin B is 2 cos A plus B by 2. Your A is 2 theta, B is 1 theta. So A plus B by 2, 2 theta plus 1 theta by 2. So the formula is 2 cos A plus B by 2 into sin A minus B by 2. Your A is 2 theta, B is 1 theta. So 2 theta minus 1 theta is 1 theta by 2. So once again the formula for cos sin A minus sin B is 2 cos A plus B by 2 into sin A minus B by 2. So that's my dx by d theta. Done with it? Of course 2 2's are 4 you can write. So 4 cos 3 theta by 2 into sin theta by 2. I'm going to pick up the y value. So y is given to be 2 sin theta minus sin 2 theta. So since y is a function of theta, I can differentiate y with respect to theta. So dy by d theta. 2 sin theta becomes 2 cos theta minus sin 2 theta derivative is cos 2 theta into 2. Inner derivative, that's what I placed here in the front. Sin 2 theta derivative is cos 2 theta into 2 times it by 2. So there is a 2 common factor, take 2 common out. So 2 into, you will get cos theta minus cos 2 theta, which looks like cos A minus cos B. And what is cos A minus cos B? Cos A minus cos B is minus 2 sin A plus B by 2 into sin A minus B by 2. So of course this 2 outside, I will copy that first, and cos A minus cos B is minus 2 sin A plus B by 2, theta plus 2 theta by 2, which is 3 theta by 2, into sin A minus B by 2, 1 theta minus 2 theta minus theta by 2. Now we have another result, sin of minus theta is minus sin theta. So this term is going to become minus sin theta by 2. And there is already a minus sign there, so double minus will become plus. So you have 2 2's are 4 sin 3 theta by 2 into sin theta by 2. So we found dx by d theta here And now we found dy by d theta, and so I can find out dy by dx, and dy by dx will be the dy answer. Dy by d theta should be divided by the dx answer, dx by d theta. So my dy by dx is dy by d theta divided by dx by d theta. So I'm going to copy my dy by d theta first. 4 sine 3 theta by 2 sine theta by 2 divided by dx by d theta. Also I copy. You can see that 4 and 4 cancel, sine theta by 2 and sine theta by 2 cancels. So what is left is sine 3 theta by 2 by cos 3 theta by 2, which is tan 3 theta by 2. We're going to look at another question now. Oh, okay, we didn't really finish it. This is dy by dx. The question actually asked you to find out the second derivative. So I'm going to differentiate it one more time. So what is the second derivative? D square y by dx square. I'm going to differentiate my dy by dx, but with respect to x, because it is d square y by dx square, differentiating with respect to x. So I read it as tan of something, tan of 3 theta by 2. Like tan of f of x becomes sec square of f of x into f dash of x. That kind of a situation. So tan of 3 theta by 2 is sec square of 3 theta by 2 into the inner derivative. What's the derivative of 3 theta by 2? 3 by 2 into d theta by dx, because we are differentiating with respect to x. So one more time. Tan 3 theta by 2 derivative is sec square 3 theta by 2 into the inner derivative. Derivative of 3 by 2 theta is 3 by 2 into theta is d theta by dx, because we are differentiating with respect to x. So I will copy this sec square 3 theta by 2 and 3 by 2. But what is d theta by dx? We already know what dx by d theta is. So dx by d theta is this. 2 cos 3 theta by 2 sine theta by 2. I took it from the other side. Dx by d theta, we had already done it. So what is d theta by dx going to be? D theta by dx will be the reciprocal of dx by d theta. So I'm going to put the reciprocal of this. So when I put the reciprocal, it is 1 by 2 cos 3 theta by 2 sine theta by 2. Is there anything cancelling? No. So either bring everything down or you shift everything up. Anyway, 3 by 2 into 1 by 2 will make it 3 by 4. So I will write that first, then move everything up. You have already a sec square 3 theta by 2, and 1 by cos 3 theta by 2 makes it another sec 3 theta by 2. So sec square 3 theta by 2 into another sec 3 theta by 2 makes it sec cubed 3 theta by 2. Into 1 by sine theta by 2 is cosec theta by 2. So that's the second derivative. We're going to look at another question now. This is if x is equal to root of sine inverse of x by 2. Okay, so this question is x is equal to root of a to the power of sine inverse of t. Root of a to the power of sine inverse of t, and y is equal to root of a to the power of cos inverse of t. And the question is to prove that dy by dx is equal to y by x. Now, this is a special question. You could still follow the same method as what we saw earlier. X is a function of t, so find dx by dt. It's a bit confusing because there are multiple times we apply chain rule. And y also multiple times chain rule I need to find if I have to do dy by dt. So usual method is to find dx by dt, then find dy by dt, and you divide them to get dy by dx and try to replace everything in t back to x and y, and finally you should get this answer y by x. But this question is a very special question. It has a shortcut which works for only for this question. It may not work with another question, but here it works so easily. And also one other thing what we notice is that there is no t in your answer. If there is no t in the answer, then probably it is possible for us to eliminate t from this question. How? Instead of x and y, I consider x square and y square so that the square root goes away and I multiply them. You will easily understand what's going on when I do the next step. What's x square times y square? X square times x square, when you say the square root is gone, so a raised to sine inverse of t. Y square, when you say square root is gone, so you get a raised to cos inverse of t. So that now looks like a raised to m into a raised to n. And a raised to m into a raised to n is a raised to m plus n. So I add the powers. But when I add the powers, I get a raised to sine inverse of t plus cos inverse of t. And sine inverse of t plus cos inverse of t is pi by 2. So I get x square times y square is equal to a raised to pi by 2. So we have eliminated t. Now if I differentiate, I should definitely get this answer directly. So I'm going to differentiate with respect to x. There is no t in the scene. This question is, we are approaching this question in a totally different way from what we discussed in the earlier question. So differentiating with respect to x, this is going to be product rule of differentiation. X square is my u and y square is my v. So u into v dash, x squared into derivative of the second. What's the derivative of y square? Derivative of y square is 2y into dy by dx. First function into x square into derivative of the second. Derivative of y square is 2y into dy by dx plus second function into y square into derivative of the first. Derivative of x square is 2x. of product rule again. First function into x square into derivative of the second. Derivative of y square is 2y into dy by dx plus second function into y square into derivative of the first is 2x. So the right hand side being a constant, it's going to be 0. Derivative is 0. And then I just try to solve for dy by dx, rearrange for dy by dx. Shifted this term to the other side, so it became negative. So now I divide. So dy by dx is equal to 2y square x upon 2x square y. 2 and 2 will cancel, 1y and y will cancel, 1x and x will cancel. So you get minus y by x. So look at this question, we did it in a special way. And there was a clue in your question because dy by dx was free of t. So probably it was possible for us to eliminate t in the scene. That's why we went for a different method in this question. Another question. If x is equal to a into sine 2t into 1 plus cos 2t and y is equal to b cos t into 1 minus cos 2t, then show that dy by dx at t is equal to pi by 4 is b by a, and then you should also find out what is d square y by dx square. So we're going to copy this term x first. X is equal to a sine 2t into 1 plus cos 2t. So I'm going to differentiate this dx by dt, but I realize that a is a coefficient which I'm going to keep outside a bracket, and between the other two terms it's product rule. So dx by dt is equal to a into first function into sine 2t into derivative of the second. 1 is 0, so I don't have to write it. And cos 2t derivative is minus sine 2t into the inner derivative 2, which I put it in front. One more time. First function into u into v dash. U is sine 2t. U into first function into derivative of the second. When I take the derivative of the second, derivative of this bracket, 1 will become 0, so I don't write it. Cos 2t derivative is minus sine 2t into the inner derivative, which is 2. So that's u into v dash plus v into, v is 1 plus cos 2t into u dash. Derivative of sine 2t is cos 2t into 2. Again, I place 2 in the front. Going to simplify it further. So a still stays outside. This first term is minus 2. Then sine 2t into sine 2t, sine square 2t. Here when I open the bracket with 2 cos 2t, 2 cos 2t into 1, 2 cos 2t. 2 cos 2t into cos t, 2 cos square 2t. And then I'm going to take 2 common factor out. So when I take 2 common factor out, 2a into, I put this positive term, the very last term first, cos square 2t, then here it is minus sin square 2t because I took 2 common out and I grouped those two. And the middle term comes last. Of course 2 is out, so you have only cos 2t. What is cos square theta minus sin square theta? Cos square theta minus sin square theta is cos 2 theta. So cos square 2t minus sin square 2t becomes cos double the angle. Cos square theta minus sin square theta is cos of double the angle, cos 2 theta. But my theta is 2t, so it becomes double the angle becomes 4t. So cos square 2t minus sin square 2t is cos of 2 theta, double the angle 4t, plus you have cos 2t. And now it looks like cos a plus cos b, and the formula is 2 cos a plus b by 2 into cos a minus b by 2. Cos a plus cos b is 2 cos a plus b by 2 into cos a minus b by 2. So this 2a will stay outside into cos a plus cos b, 2 cos a plus b by 2. 4t plus 2t, 6t divided by 2 makes it 3t. Into cos a minus b by 2. 4t minus 2t is 2t divided by 2 is 1t. So we get 2 cos 3t into cos t. Now of course 2 2's are 4 there. So your answer is 4a into. Okay. Now I'm going to copy my y and do dy by dt. So that's my y. So when I do dy by dt, again product rule, I'm going to keep this b outside being a coefficient. Now my first function u is cos 2t. So cos 2t into derivative of the second, 1 is 0, minus cos 2t derivative is minus sin 2t. So minus minus is plus sin 2t. There is no minus sign here. Double minus comes into the inner derivative, which is 2 here. So one more time, u into cos 2t into v dash derivative of the second, 1 is 0, minus cos 2t is minus sin 2t into 2. But double minus became plus, and that's why I don't have a minus sign there. Plus second function into, so I copy my second function into derivative of the first. What's the derivative of cos 2t? Minus sin 2t into 2. And again I have got this 2 common factor which I bring out, so 2b. 2 is gone out, so this is sin 2t cos 2t. And here 2 is gone out, so I have only minus sin 2t, with which I open the bracket. Minus sin 2t into 1, minus sin 2t, minus sin 2t into minus cos 2t, which is sin 2t cos 2t. Then this first term and the last term, when you add, it's the same thing. So it's going to be 2 times sin 2t cos 2t. And the second term, we copy the same. So the first term, cos 2t, sin 2t cos 2t, plus again sin 2t cos 2t is 2 times sin 2t cos 2t. But then it looks like 2 sin theta cos theta, which is sin 2 theta. So 2b into sin 2 theta, sin of double the angle. 2 sin theta cos theta is sin 2 theta. So it became sin 4t minus sin 2t. Then that looks like sin a minus sin b, and I have the formula here. What's sin a minus sin b? 2 cos a plus b by 2 into sin a minus b by 2. So let me do that. 2b into 2 times cos of a plus b by 2. 4t plus 2t is 3t divided. 4t plus 2t is 6t divided by 2 is 3t into sin a minus b by 2. 4t minus 2t is 2t divided by 2 is t. So that is sin a minus sin b. 2 cos a plus b by 2 into sin a minus b by 2. Of course 2 2's are 4. So 4b into cos 3t into sin t. So we found dx by dt, then we found dy by dt. So we are going to find dy by dx. So dy by dt by dx by dt. Divide the dy answer by the dx answer. Copy the dy answer. 4t cos 3t sin t divided by dx answer 4a cos 3t sin t, which gives me b by a, and then sin t by cos t is tan t. Cos 3t and cos 3t cancels, 4 and 4 cancels. So b by a tan t. But they wanted the value of dy by dx when x is equal to pi by 4. I'm sorry, t is equal to pi by 4. The parameter t is equal to pi by 4. So you replace t by pi by 4. So b by a into tan of pi by 4, which is b by a into 1, which is b by a. But we also have to find out d square y by dx square. So I'm going to copy my dx by dt, my dy by dt, and my dy by dx one more time. So I had this as my dx by dt, I had this as my dy by dt, and I found dy by dx, which is b by a tan t. And don't take this specific value which we found when t is equal to pi by 4. No, we are working on d square y by dx square. Okay. So you need to get the general answer, and if you have a specific value given as like t at t is equal to pi by 3, then you put t is equal to pi by 3 into the final answer. So we are now working on the general answer. So dx by dt is b by a tan t. So what is d square y by dx square? B by a is coefficient which will stay there, and the derivative of tan t will be sec square t, but into the inner derivative dt by dx. So let's write it. B by a into tan t becomes sec square t into dt by dx. But what is dt by dx? Is the reciprocal of dx by dt. That's why I copied and kept it ready there. I know what my dx by dt is, so dt by dx would be the reciprocal of it. So b by a sec square t into reciprocal of dx by dt. You have a sec square t there, you have another sec t here, 1 by cos t is sec t. You could make it as sec cubed t, and this is going to be sec 3t. Or you could bring everything down and put it in cos. So I put everything up there, sec square t into another sec t from here, makes it sec cubed t, and 1 by cos 3t is sec 3t. We're going to look at another question. X is equal to a into theta minus sin theta, y is equal to a into 1 plus cos theta. Find d square y by dx square. Here the parameter is theta. X is written in terms of theta. Y is separately written in terms of theta. So this is parametric. So we're going to copy our x value, x is equal to a into theta minus sin theta, and find dx by d theta. So dx by x is a function of theta, so I find dx by d theta. A is coefficient which stays there. Derivative of theta is 1 minus derivative of sin theta is cos theta. But immediately strikes me that 1 minus cos theta is 2 sin square theta by 2. So I want to apply that formula. If there is a formula available, I want to apply it. 1 minus cos theta is 2 sin square theta by 2. I applied that formula. Now I'm going to go to y and then find dy by d theta, because y is a function of theta. So find dy by d theta. So dy by d theta will be a into 1 will become 0, and derivative of cos theta is minus sin theta. Now I face a problem. I change my dx by d theta in terms of theta by 2, half angle. So I want even my dy by d theta to be in half angles. So this is going to be minus a outside, and sin theta has a half angle result. Sin theta is 2 sin theta by 2 cos theta by 2. So sin theta as half angle result we write 2 sin theta by 2 cos theta by 2. So one more time. A is the coefficient which stays outside, 1 will become 0. Cos theta derivative is minus sin theta. Derivative of cos theta is minus sin theta. And sin theta half angle result is 2 sin theta by 2 cos theta by 2. So I'm going to find dy by dx, and dy by dx will be dy by d theta divided by dx by d theta. I'll copy the dy by d theta value first, divided by dx by d theta value, and see what happens. 2 and 2 will cancel, a and a will cancel. Sin theta by 2 and 1 sin theta by 2 will cancel, which gives me minus cot theta by 2. But your question is to find d square y by dx square. So d square y by dx square would be, there is already a minus sign which I copy, and cot theta by 2 derivative is minus cosec square theta by 2. Derivative of cot x is minus cosec square x. Derivative of cot theta by 2 is minus cosec square theta by 2 into the inner derivative 1 by 2 into d theta by dx. And of course, d theta by dx is the reciprocal of dx by d theta. So I'm going to put that value. So minus minus is plus cosec square theta by 2 into 1 by 2 into reciprocal of dx by d theta 1 by 2a sine square theta by 2. 1 by 2 into 1 by 2a is 1 by 4a, and cosec square into another cosec square theta by 2 makes it cosec raised to 4 theta by 2. Should take time to pause the video and write the answers down, or do it yourself and come back and check if you are not able to do it. One more question, last question on this. If x is equal to a sine t, y is equal to a into cos t plus log tan t by 2, find d square y by dx square. I'm going to find dx by dt. A sine t derivative, x is a sine t, so dx by dt is a into sine t derivative is cos t, and that's it, we are done. Y is given to me like that, so I'm going to differentiate it. Dy by dt would be a into derivative of cos t is minus sine t, derivative of log of f of x would be 1 by f of x into f dash of x, the inner derivative. So log of tan t by 2 would be 1 by tan t by 2 into the inner derivative. Derivative of tan t by 2 is sec square t by 2 into 1 by 2, the inner derivative. So I differentiated y with respect to t. Going to do a little bit of simplification there. That's why this question is important. So a stays outside. Into inside the bracket I have minus sine t, 1 by tan t by 2. 1 by tan t by 2 is cot t by 2. And cot t by 2 is cos t by 2 by sin t by 2. Into sec square t by 2 is 1 by cos square t by 2. Into this 1 by 2 I kept the same. You can see that 1 cos t by 2 from the denominator will cancel with the cos t by 2 in the numerator. Now what do you have in the denominator here? 1 by 2, I have a 2 here, sin t by 2 cos t by 2. So isn't it 1 by 2 sin t by 2 cos t by 2, and 2 sin theta by 2 cos theta by 2 is sin theta. 2 sin t by 2 cos t by 2 is sin t. And then I'm going to take LCM inside the bracket. So when I take the LCM inside the bracket, there is an a outside. When I cross multiply, it's going to be minus sin t into sin t. When I cross multiply like that, so I'll get minus sin square t plus 1 by sin t. That's actually 1 minus sin square t by sin t. But 1 minus sin square t is cos square t. So I get a into cos square t divided by sin t, which is here dy by dt. Now that we have both dx by dt and dy by dt, I can find dy by dx, which is dy by dt divided by dx by dt. I copy my dy by dt divided by dx by dt, which is a cos t. And to divide, I multiply with the reciprocal. So into 1 by a cos t. Then I can see a and 1a and a cancels, cos t. 1 cos t from the numerator and the cos t from denominator will cancel. So a and a gone, cos t and 1 cos t gone, balance is cos t by sin t, which is cot t. So that's going to be my dy by dt. So what's your d square y by dx square going to be? Derivative of cot t is minus cosec square t into dt by dx. And what is dt by dx? Dt by dx is the reciprocal of dx by dt. So that's 1 by a cos t. Which is your answer? Of course, this 1 by I place it in front, and 1 by cot t can be 1 by cos t can be put as sec t. Cosine square t stays the same. Or you could put everything in the denominator in terms of sine and cos. What you need to do is you need to really write and practice these questions. Copy down the questions, do it yourself. If you can't really understand it, pause the video, copy down the answers. I'll see you in the next video.